Hey guys, happy Thursday. I promise that I will be in tomorrow. So at this point on Monday, you learned about dilations, about the origin, and about a point that's not the origin. You have done similarity transformations. So you've done a dilation and a translation, a reflection and a dilation, a rotation and a dilation. And then yesterday you guys practiced mapping, so taking an object onto another object, but this time we also included dilations as well. And you also practiced proportions yesterday because we're going to be needing them today. So do now real quick, determine the value of x. Pause the video for a second and see if you can determine the value of x. Once you're finished, come back. Okay, I have two proportions with an equal sign in the middle, so I'm going to cross multiply. This will become 4 times x minus 4 is equal to 3 times the quantity 2x plus 1. Distribute. 4x minus 16 equals, distribute again, 6x plus 6. I'm going to move my 6x. I'm going to add my 16. I will get what? Negative 2x equals 22. Divide by negative 2, x equals negative 11. All right, hopefully you got the answer of negative 11 when you solved this proportion. Okay, so getting into what we are going to be learning today. Today I can set up and solve proportions with similar figures. So we're going to be setting up and solving proportions, but today the proportion will not be given to you. You will have to set it up. Just some reminders, quarter 2 does end tomorrow. I will be back tomorrow. And then you will have a quiz the following week and so forth, and your test is coming. Just, you know that. Okay, so make sure that you have a blue sheet. Those are your notes for today. So if you haven't glued them into your notebook yet, go ahead and pause the video and glue them into your notebook. When you finish with that, come back to the video. Okay, so we've talked about things being congruent before. We know that congruent means equal. So if I tell you two shapes are equal, two shapes are congruent, we know that all their sides are congruent, all the same, and we know that all their angles are the same. They're congruent. This chapter is about similarity. We're having dilations. We know that dilations mean that things are not congruent. So if shapes are similar, here's what we know. Corresponding angles, that would be angles in the same location, corresponding angles are congruent that would be the same if we had congruent shapes as well. Corresponding angles are congruent. So nothing new so far. It's the second bullet where things change. Corresponding sides. We're used to corresponding sides being equal when we're dealing with congruency, but now that we're dealing with similarity, they're not equal. Corresponding sides are proportional. Which is why we practiced solving proportions, because today and tomorrow we're going to be setting them up. So if triangle ABC is similar to triangle DEF, I'm going to tell you to stop, pause, draw this out. So triangle ABC, doesn't matter where I put A, B, or C. I just need to make sure that I put them, make sure they go in a circle. Similar to triangle DEF. So since they're similar, they're not going to be equal in size. So I'm going to maybe make this one a little smaller. You could make it bigger. They just can't be equal to each other. Now, D has to go where A is. Because again, we can look up here. A is in the same location as D, so D needs to go in the same location. B goes with E, so E would go up there. And C goes with F, so F would go there. Okay, now that we know that, let's see if we can figure these out. Angle A. Angle A would be equal to what angle in the smaller triangle? Angle D. Okay. Angle B. Angle B would be equal to angle E And then last but not least, angle C would be equal to angle F. That goes with our first bullet up top. Corresponding angles are congruent. Okay, second part here. Corresponding sides are proportional. Okay, so AB over BC is equal to. Okay, well, let's think about this. My numerator is AB. So what side goes with AB? Oh, BE. My denominator is BC. That's this side. What side goes with BC? EF. Okay. Same thing for the next one. Okay, AC, that's down here. And AC would go with, AC would go with DF. And then BA is this side. It's going to go with ED. Last one here, whoops. CB over CA. Okay. CB is this side. Well, that's going to go with this side, which is going to be EF, over CA, which is the bottom, which is going to go with FD. So hopefully that makes sense there. That's our second bulletin. Corresponding sides are proportional. So you're going to be setting up a proportion dealing with corresponding sides. Now, obviously, when I give you some examples, there's going to be some unknowns here because we have to solve a proportion. For example, and I believe you also have this, yes, on your blue sheet. If triangle ABC is similar to triangle DEF, again, they're giving me this situation. So let's see, since they're similar, I know angles are congruent, and I know sides are proportional. And again, they gave me the letters. They also gave me pictures. It looks like A and D are in the same spot, B and E are in the same spot, C and F are in the same spot. So they didn't try to trick me here with a picture. So that's good. Use the information below, I don't know, to determine the value of X. Okay. I see X. X is on this side. X goes with DE. So I have to kind of ask myself, what side in the smaller triangle corresponds with DE? That would be AB. Okay. I can set that up right there as part of my proportion. 10 goes with X. If you want to write that as X over 10, that's totally fine as well. Is equal to. Okay, well, let's look here. We were given a 6 and we were given a 12. Do you agree those are also corresponding to each other? I do. 6 is going to go on the numerator because 6 goes with 10. Does that make sense? My numerators are from triangle ABC, and my denominators are going to be from triangle DEF. So what goes with 6? Side 12. Okay, now it's just exactly what you were doing yesterday, and I'm going to do now. Cross multiply and solve. That gives me 6x equals 120. Divide both sides by 6. X equals 20. Okay, not too bad for our first example. Let's look at our second example. And I apologize, I think on your sheet, on your blue sheet, yeah, for some reason these two got flip-flopped. So make sure that you're doing the second problem first, if that makes sense. So if we look at this first problem, it says, given that the triangles below are similar, determine the value of X. Okay. It says ABC is similar to XYZ. They gave me pictures. A and X seem to be in the same spot. B and Y are in the same spot. C and Z are in the same spot. Doesn't look like they gave me a picture here that's going to be confusing. It looks pretty good. Okay, so I have to find X. So again, X is AC. Okay, well, what side corresponds with AC? Oh, XZ. Perfect. There's one side of my proportion. Now, they also gave me side 25, AB. Okay, so does the 8 or the 10 correspond with 25? The 10 does, XY. So this will be 25 over 10. And here, pretty simple, cross multiply and solve. 10x equals 150. Divide both sides by 10. X is 15. Okay, that's not bad. Let's look at this next one now. A, B, C is similar to X, Y, Z. Okay, they like to confuse me here. They like to give me pictures that are going to confuse me. Personally, I would rather have the first example. Those pictures are really nice. They are in the same kind of orientation. Of course, over here, something gets flipped. So you know what I'm going to do? I am going to redraw this triangle so that it looks like triangle ACB. So, if I were to redraw this triangle, excuse me, let's see, what goes with A? X. So X will go up top. My right angle will go on the bottom. C goes with Z, and B goes with Y. Now those two look better to me. They look in the correct orientation. Now we just need to fill it in. So you told me, let's see, they said YX is where my X value is. So I'm going to put my X value here, and then they gave me YZ is 20. Okay, perfect. So I've now taken this triangle and made it look better. Not really better, but it just makes more sense to me now. Okay, so let's see. Gotta find X. Here's X. What side corresponds with X? Oh, 50 does. X over 50 equals, okay, back to my smaller triangle, 20. What corresponds with 20? 40. Okay, now, very simple, cross multiply. 40x equals 1,000. Divide both sides by 40. X is 25. Okay, not too bad. Let's keep going. I think on the bottom there you have 4 more examples. Okay. In the diagram below, angle D is equal to angle K, okay, as they have marked, you know, angle D equal to angle K, and then they have angle A is equal to angle M, okay? So the triangles are similar. Okay, they're telling me the triangles are similar, but of course they're not giving me letters here, but okay, fine. If RM is 14, MA is 16, DK is 11, determine length of KR. Okay, be very careful here. This is the problem. This is where a lot of people are going to make a mistake and set up incorrect proportions. You have to remember that in order to set up proportions, we have to have similar shapes. So we have to have the same shape. A lot of people will try to set up 16 over 14 equals 11 over x, because it's kind of the proportion you can actually see right here. But you have to think about this. When you're talking about 16 corresponds to this right here. You're talking about 11. That's going to correspond to this part right here. I'm pretty sure if I were to connect that, that shape is not a triangle. When down here, when you're using x and 14, you actually have a triangle. So you cannot compare a triangle to a trapezoid. We cannot do that. We have to make sure that we're comparing a triangle to a triangle, or a trapezoid to a trapezoid, or a parallelogram to a parallelogram. They have to be the similar, same shape. So if I believe I might have 2 triangles, actually, in this picture. Sorry, I'm just getting rid of this. So I'm going to redraw them. Let's see. I see this pretty small triangle down here. Pretty simple. Right? We know that this is M. We know that this is K. We know that this is R. They told me this is 14. They told me this is X. That makes sense. Now the other triangle, because again it has to be a triangle, I see, is the big triangle. Now what goes with M? A. What goes with R? R. What goes with K? G. Okay. Now we got to fill in our sides. AR. AR is all of this. So I'm going to add 14 plus 16 and get 30. DR. DR is all of this. Be very careful right here. Think about how we got 30. We added 14 and 16. So make sure that you add 11 and x. Do not multiply them. This will become x plus 11, or you could say 11 plus x. Now I have 2 triangles. They already told me they're similar. Now I can set up and solve my proportion. X goes with side, x plus 11 the way 14 goes with 30. Okay? Let's solve this then. 30x equals, be very careful here, 14 times the quantity x plus 11. 30x equals, a lot of people will forget to distribute here. 14x plus 154. Subtract 14x. 16x equals 154. Divide both sides by 16. X equals 9.625. That's fine. Okay? Just remember, you have to compare a triangle to a triangle, or a trapezoid to a trapezoid, or a rectangle to a rectangle. You cannot compare shapes that are not the same. Okay? All right, 3 to go. 2 triangles are similar. Okay, well, you know what? I'm going to draw myself 2 triangles that are similar. Perfect. Okay. If the sides of the smaller triangle are 3, 4, and 6. Okay, it doesn't really tell me which one's which, but I guess it doesn't matter. I'll call this one 3, I'll call this one 4, I'll call this one 6. Sure. And the smallest side of the largest triangle is 16. Okay, so it's going to be specific as to where I put that. Well, let's think. What's the smallest side of the smaller triangle? 3. Okay, so my 16 is going to have to go in the corresponding spot, which would be down here. That would be 16. Determine the length of the largest side of the larger triangle. Okay. Where does my x go? Does it go on the right side? Does it go on the bottom? Well, let's think. Where's the larger side of the smaller triangle? Is it 4 or is it 6? Oh, it's definitely 6. So my unknown, my x value, will go here. Now, set up and solve this. Smaller side over smaller side equals larger side over larger side. 3x equals 96. Divide by 3. X equals 32. Okay, hopefully you're getting it. Hopefully it's starting to make sense. We got 2 more. If Samantha, it's a really pretty picture there of Samantha, is 2 meters tall and standing 3 meters from her car, how tall is the tree below that is 30 meters from the car? Whoa, okay. Samantha's 2 meters. She's 3 meters from the car. Tree is 30 meters from the car. We have to figure out how tall the tree is. Okay, so I'm going to assume that this is going to be the height of the tree, which is going to be my unknown value here. Okay. Well, if I go back to this problem, I remember that I have to compare similar shapes. So let's see if I have 2 shapes in here that I can see. Oh, wait a minute. I think I see a triangle here. I have the small triangle, which would deal with Samantha and her distance from the car. Then I also believe I have a large triangle here that will deal with the tree and the tree's distance from the car. So you know what? Let's separate them. We have our small triangle here. Samantha is 2 meters tall. She is 3 meters from the car. We have our larger triangle. We don't know the height of the tree, but we know that the tree is 30 meters from the car. I believe now we can set up and solve a proportion. X goes with 2, the way 30 goes with 3. 3x equals 60. Divide by 3. X equals 20. Again, separating the same shape. We have to compare similar shapes here. So I looked at this and I said, oh, okay, I have 2 triangles in here. So I then redrew them, filled in my unknown information, and solved for x. All right, last one. Of course, you all know this is going to be the hardest one, right? Kara is looking up at a flag on her college campus and wonders how tall it is. Okay, She knows that she is 5 feet 3 inches, her shadow is 11 feet, and the flagpole has a shadow of 23 feet. How tall is the flagpole to the nearest foot? Okay. So I believe we need to find how tall this flagpole is, yes? I believe this is X. And we're dealing with a shadow here. So I'm thinking that's going to kind of make a triangle. So if I think about this, I have the flagpole. The height of the flagpole, we don't know. I have the shadow of the flagpole is 23. Kind of makes a triangle right there. Okay. Now I'm also dealing with a height of Kara and a shadow for Kara. So I'm thinking that's going to make another triangle. Oh, same shape. They're similar. My shadow is 11 feet. Here becomes the issue. The shadow for the flagpole is 23 feet. The shadow for Kara is 11 feet. Kara is 5 feet 3 inches. That is not 5.3 feet. Okay? Not 5.3 feet. So, we got to figure out exactly what it is. It's definitely going to be 5 point something. So we have to look at this. I'm hoping you all know that a ruler is a foot and that there are 12 inches in a ruler. So we have to think about this. If Kara is 5 feet 3 inches, that would mean she's 3 inches out of a total foot, which is 12, which I believe becomes 0.25. So instead of 5.3, that is not 5 feet 3 inches. It is actually 5.25. Now that we know that, this problem is easy. Set up and solve our proportion here. X goes with 5.25 the way 23 goes with 11. All right, now also notice it said to the nearest foot. So I'm assuming, actually yours doesn't say that, but I would like the answer to the nearest foot. 11x equals, oh man, definitely get a calculator here. 120.75. Divide both by 11. X equals 10.977 something, which rounded to the nearest foot is 11. Hopefully this makes sense. At the end of the day, similar shapes have corresponding congruent angles and proportional congruent sides. Again, I will be in tomorrow. Tonight, make sure that you practice page 10. I will answer any questions tomorrow on dilations, similarity transformations, mapping, and then setting up and solving proportions with similar figures. Enjoy your night. I will see you tomorrow.